So here are the commands that are used for creating jobs and steps. SBatch submits a script for later execution. That's your batch mode. You submit it, you walk away. Whenever it starts and runs, you'll find out about that and you'll get your files. salloc is an interactive mode, so it creates a resource allocation, and you would typically use it to start a shell which would be attached to that allocation. So when you start job steps, they're going to use those resources. srun will create a job allocation if it's not running from within one, and launch a job step, which is typically an MPI job. And sattach can connect the input, output, and error files for an existing job or job step. And I'm going to give some examples of these. So if you want to submit a batch job, here are a few examples. The first one, I want to run one task. I want it to have a 10-minute time limit, and the name of the script I want to execute is pre_process.bash, and it's just going to come back with either an error message if something bad happened, or it's going to say I submitted batch job and give you a job ID. The next example has a batch job being submitted that needs 128 tasks, and it's going to run for 60 minutes, and it's dependent upon the previous job. There's a depend equals job ID there. And the last one is a job for post-processing, which uses one task and has a 30-minute time limit and is dependent on your main job completing. Here's an example where you're creating a job allocation for 2 tasks and running something on that allocation, all in a single operation. So srun --end task, 2 tasks. -- label just means prepend on each line of output the task ID and the host, and then a colon. And in this case, we're just running host name. So this is running 2 tasks that print the host name, and they're allocated on the same node in this example. The next example shows you if you want to run on 2 whole nodes, get exclusive access to 2 whole nodes. And the output looks the same pretty much, except your output is from 2 different nodes, because one task ran on one node and the other task ran on a different node. The next example is a interactive mode of operation where you run salloc to create an allocation. In this case, I'm asking for resources to run 8 tasks for a 10-minute time period. And it'll wait until those resources are available, and once those resources are available, it will launch the program, in this case a bash shell. I just show a command here where you're printing up some environment variables where you'll see what some of the environment variables are. Nprox is the number of processes that have been allocated, a list of nodes that have been allocated, and then if you run hostname, it will print up where you actually executed the salloc from, which is where the bash shell is running. So that would typically be a login node. But if you run the srun command from within there, it's going to launch those tasks on the resources that have been allocated to your job, which wouldn't be your login node, but would be a compute node, or in this case 2 compute nodes. And then when you exit the bash shell, that allocation is relinquished. Slurm can also execute different programs on different task IDs. So in an example shown below, you might launch 5 tasks, and task 0 runs a program user/me/master, and the tasks 1 through 4 are launching a program called user/me/slave, and the input to those programs for tasks 1 through 4 is -- rank equals whatever the task ID is. Anyway, Slurm supports many different MPI implementations, and there are dozens of them available. Many use srun to launch the task directly, so you would just do srun, number of tasks in your executable. Some flavors of MPI rely upon MPI run or some other tool to launch the task, and they would typically use the Slurm environment variables that I showed you a couple of slides ago to determine which resources they're supposed to use. And there's several pages of information that detail how the different MPI implementations use Slurm at the website shown there. Now I'm going to go through what the operation is to launch a job. So just walking you through step by step. So in this case, we don't have a resource allocation. We're just going to run srun. So srun is going to send a request to the Slurm control daemon. The Slurm control daemon is going to grant the allocation and respond to srun with information about what resources have been allocated to the job. The srun will then, as a separate step, create a step allocation, send that request to the Slurm control daemon, and the control daemon will respond with a step credential. Now that credential is a digitally encoded credential that has information about what resources have been allocated. The srun will open up some communication sockets for the I/O and then forward that credential with the task information to SchedMD on node 0 of its allocation. That SchedMD will forward the information to whatever other compute nodes, the SchedMDs and whatever other compute nodes are using that allocation. And that will fork and exec the Slurm stepd, which, as I said, is the shepherd for the job steps. That will connect up to the sockets which srun opened up for the I/O and launch the tasks. When the job completes execution, the task complete, the Slurm stepd notifies the srun program over those sockets, and the srun notifies the Slurm control daemon of the job termination, and the Slurm control daemon then talks to the SchedMDs to make sure all the processes have terminated. So you'll note that the Slurm control daemon doesn't even talk with the SchedMD daemons until it's time to terminate the program. So as part of the resource allocation and task launch, there's no direct communications between the control daemon and the SchedMD. The credential is what is used to authenticate the resource allocation.